Hello, welcome. So we continue again with our tutorial sheet. Alright, so basically what we're doing is literally on the same thing. So about showing if the dimensions are correct, so about finding the dimensions of the constant and relating to quantities. Yeah, I really feel like you get it, maybe, but I hope you get it. So if you look at this question, for most of you, I bet you already know this. This question reads: the kinetic energy Ke in topic 5 has the dimensions that are given as these: kilogram meters squared second to the minus 2. Can be written in terms of momentum P and the mass M. Okay, as it is. Now let's say determine the proper units for momentum using dimension analysis. Okay, so when they say kinetic energy is equivalent to momentum squared over 2m, like that, they want us to find the dimensions of what? P, isn't it? So not the dimensions, the proper units of P. So in order for us to find the proper units of P, the first thing we're supposed to do is to find the dimensions of P. Now how do we do that? Remember, in order for you to find the dimensions of the constant, forget about the numbers, forget about the trig ratios, forget about the e or the pi's, just consider what you have. So I now have kinetic energy is equal to what? P squared over what? M. Now what else should you put in mind? The constant should be always made what? The subject of formula. So I say over 1, and I'll be having P squared is equal to K E times M. Isn't it? So now I'm trying to make P the subject of formula, not P squared. So what should I do? I eliminate the squared by square rooting both sides. This guy goes with that guy, and I have P, which is the momentum, being equal to the root of kinetic energy by the mass. Now let's write the dimensions of these. But from the question, if you remember, it is given in this form. The kinetic energy, according to the data we have, the kinetic energy has the dimensions kg m squared dot s to the minus what? 2. So now what would be the dimensions, which means Ke is equal to kg is the mass, so capital letter M, then M is meters, so we say capital letter L squared dot S is time minus 2. So you know that whenever you have a minus 2, this can also be written in this format. Then we say over to what? To the power 2. Mathematically we are allowed to do that. Just to review, if I have a to the minus something, a to the minus something over 1, this is the same as 1 over, remember, minus something, so it will be 1 over a to the positive something. Don't forget that. So I'm having these dimensions for kinetic energy, so I'm going to put them here. So I have M, I have L, and I have the time, multiplied by this other guy, the mass, like that. So if I follow it out, momentum is equal to M times M. I have M squared, then I have L squared, then I have T squared. Mathematically, this is written as the root of M squared root of L squared over root of T squared. So this cancels with that, this with that, this with that. So momentum is equal to M L over T. These are the dimensions of momentum, but our interests are the units. Now that you have the dimensions, you can now get the units. M represents the mass, so you say kilograms. L represents the length, so meters, over time, which is what? Seconds. Alright, so this can also be written as P is equal to kg ms minus 1. And that's your final answer. Alright, so the second part B will be in a video. Alright, don't forget to like and subscribe to the channel.